Hi, I'm Miss Amsara and today I will teach you about integration. We will start our video with the area problem. So here I have a graph where the curve represent is y is equal to fx. So the question here from this graph is how can we find the area under the curve? The area under the curve can be calculated by using integration, which is the formula the integration of b to a in terms of x. To make it easy for us to indicate we are doing integration or differentiation, this is the integral symbol. This is the notion of the integral, which is connected to the notion of the derivative and the notion of the antiderivative. As we know, derivative and antiderivative are related to each other. Derivative can be defined as the slope of a tangent line, whereas the antiderivative is essentially the reverse process of differentiation. The most important thing that we must remember is both derivative and antiderivative is connected to each other. For example, we can reverse the differentiation process to find an antiderivative for a function f.
As I said earlier, both integration and differentiation has a close relationship with each other. So let's say we have a function fx plus c. So when we differentiate this function fx plus c, we will get f prime x. We can say that the derivative of fx plus c is a function of f prime x. Next, when we integrate f prime x, it is equal to fx plus c. So we can say that fx plus c is the antiderivative of f prime x.
Next, we will proceed to the indefinite integral where we will learn about the antiderivative. An antiderivative of a function f is a function whose derivative is f. In the other words, when f is an antiderivative of a function fx, if f prime x is equal to fx. Next is the theorem. This theorem explains about when we have an antiderivative of fx from the function fx, and when we add a constant c to it, the result that we get is fx plus c, which also an antiderivative of fx. Next, I will show you how can we do the integration step. We can do the integration by using this formula.
As I said earlier, there is a basic equation that we will use to solve the integration, which the equation are integrate fx dx is equal to fx plus c. So this is the basic integral question. The first question asks integrate 4 dx. To answer this question, we just need to add x to the 4 and add our constant. We need to remember that every time we integrate, we need to add our constant c. Next, the second question asks integrate pi dx. So, the answer that we get is pi x plus c. This is the same step as the question number 1.
Hi everyone, my name is Miss Asma. Before we learn about integration formula, we will recap the basic of differential. Alright, what do you know about differential? dy ds? Differential is defined as a derivative of a function with respect to an independent variable. It can be calculated by using the power rule where d over ds of Sn is equal to nx power of n minus 1. Next, the integration formula. There are many integration formula that we will learn in this topic, but I want to focus on the 3 basic of integration formula. First, integral of Sn ds is equal to x power of n plus 1 over n plus 1 plus c. Second integral of sin x dx is equal to negative cos x plus c, and the last one is integral of cos x dx is equal to sin x plus c. We will do some example to know how to use all this formula.
Hi everyone! Today, Miss Asma want to explain about how to apply the integration formula that we had learned before. Firstly, we will see the question given is evaluate the integral of 3x seed minus 2x squared plus 7x plus 1 dx. Next, from the question, we will see what formula should we use to solve this question. This question is a basic integral, so we will use formula of integral xr dx is equal to xr plus 1 over r plus 1 plus c. Then we will solve this question by using this formula where integral of 3x seeds minus 2x squared plus 7x plus 1 dx is equal to 3x 6 plus 1 over 7 minus 2x 2 plus 1 over 3 plus 7x 1 plus 1 over 2 plus x plus c. So the answer for this question is 3x 7 over 7 minus 2x 3 over 3 plus 7x 2 over 2 plus x plus c. So that's all. Easy, right? Next, we will move to the next question. Alright, next for this question, we should evaluate the integral of cos 3x dx. From what we learned before, we will use this formula where integral cos x dx is equal to sin x plus c. Next, we will solve this question by using this formula where cos 3x dx is equal to sin 3x over d dx 3x plus c. So the answer for this question is sin 3x over 3 plus c. That's all. Easy, right?
Hi students! So here you are with me, Miss Ira, in order to help you guys in mastering another integration example. Do you still remember this kind of equation? So let's learn basic integration exponential function. As you can see here, we have integration exponential to the power of x equal to exponential to the power of x plus c. My question is, how can we apply this? For your information, exponential integration is the opposite of exponential differentiation. So, if you remember, when we differentiate exponent to the power of x, it stays as exponent to the power of x. So, it implies the same thing when we integrate. Do not worry, here I want to share some tips that you may apply to integrate this special formula. There are 6 steps that you have to follow. Okay, now I want to highlight the basic example of equation first, which is y equal to the integration say exponential to the power of 3x minus y respect to x. Okay, so if you want to solve the equation, you can choose one method, either reverse chain rule or use substitution. So in this case, I'm gonna teach you reverse chain rule method since it's more quicker than the other one. Okay, first thing first, if you have the coefficient, you can take it out first, so you can just work with the exponent. Okay, if you want to integrate this, you will have to differentiate 3x minus 1 first. Then it will be 1 over 3 exponential to the power of 3x minus 1 and then plus c. Okay, we can simplify this, become 2 exponential to the power of 3x minus 1 plus c. Okay, if you can mastering this kind of equation, you can solve the harder one. Okay, let's look at another example. So here we need to integrate 2 exponential to the power of 5x respect to x. Okay, so as usual, we can take out the coefficient, which is 2. Okay, so in the bracket, we need to copy down the number before the polynomial. But here only exponential, so we write down 1 here. Okay, if we integrate function, we will have the exponential back. Okay, do not forget to pair with a below 1. Okay, to identify a, you may find out the number before the polynomial. Okay, then copy all the polynomial back. The last one, do not forget to simplify the equation. Okay, I'm going to focus on the basic example first. Okay, as you can see here, we have integrate 5 over bracket 2x plus 3 respect to x. Okay, so we have here 5 ln modulus 2x plus 3. Okay, we put modulus since we can't put negative into ln, so it's not defined, so we can't do that. Okay, next we are going to divide by the bracket differentiation, which is 2. In this case, it gives us 5 over 2 ln modulus 2x plus 3 plus c. Okay, that's all from me. Thank you.
Okay, so I will continue with the properties of indefinite integral. So basically, there are 3 theorems you need to understand. Okay, the first one, a constant factor can move through an integral sign. So a constant factor is a number, and it means small letter c here, which is a constant factor, can move through an integral sign. And after you complete the integration process, you just need to multiply it back. For the second theorem, is an antiderivative of a sum is the sum of antiderivative. And for the third theorem, an antiderivative of a difference of the antiderivative. So basically, theorem 2 and 3 have similarities, okay, which is they have a same pattern, which is we can separate fx and gx and settle the integration part one by one. However, you need to remember it's only valid for addition and subtraction only. So without further ado, let's continue with the example part. Okay, for the first question, we just need to move the 3 from the integral sign. So we just have exponent 2x plus 1 dx. So just settle the exponent part and we will have 3 exponent 2x plus 1 over 2 plus c. So the final answer will be 3 exponent 2x plus 1 over 2 plus c. For the second question, we have integration of, in bracket, x plus x squared dx. So we will use theorem 2, which is we can separate it into 2 parts. Okay, so let me show you how we separate it. So it will look like this. So after that, you just integrate it one by one. So we will get x squared per 2 plus x cubed per 3 plus c. Okay, for the third question, the first thing first, we need to separate it. So we will have t squared over t to the power of 4 minus 2t to the power of 4 over t to the power of 4 bracket dt. Okay, for the next step, we simplify it, so we will get this. Okay, only have 2, so just copy what we have. So we have t to the power of negative 2 minus 2 dt. So, we integrate 1 by 1, so we will get negative 1 over t minus 2t plus c.
Hey there, teacher Macwizers! Today, we're diving into the fascinating world of integration by substitution. But don't worry, I promise to keep it simple and fun. So grab your math notebook and let's get started. Alright, let's start with the basic. Integration is like reverse engineering, finding the original function from its derivative. But sometimes, things can get a bit tricky where we found some complex function, and that's where the substitution comes in. Imagine it as a superhero swooping in to save the day. Now, let's talk about the chain rule. Hopefully, we all remember the chain rule from differential calculus. It's like solving a puzzle where we have to peel off one layer at a time. Similarly, the chain rule helps us break down complex functions into simpler parts. First up, imagine we have a function inside another function, like hx is equal to fgx. The chain rule helps us find the derivative of this composite function. It's like peeling off layer to see how fast things are changing. If fx is our outer function and gx is the inner one, the chain rule said that the derivative hx is given by fgx times g prime x. Now, let's jump over to integration by substitution. This is like going into the reverse direction. Suppose we have an integral that is a bit tricky, for example, this equation. We want to simplify this. Here's where the magic happens. We make a substitution. We let u equal to gx, so derive this into this equation. Now, as you can see, we're essentially replacing the inner function with a new variable. When we substitute u and du into our integral, something neat occurs. The messy integral becomes an integral in terms of u. It's like we're untangling the mess to make it simpler. After finding the antiderivative with respect to u, we can switch back to our original variable x if needed. Let's look at normal method problem. So in this example, we are given this equation. First, we must see whether it can be simplified or not. If it is already in the simple form, next, we just need to integrate it term by term. So, in step 2, integration of cos 5x dx is equal to sine 5x over d dx times 5x. Next, derive the 5x, it will become sine 5x over 5. And don't forget to plus with c. Simple and fast, right? Now, let's solve the same problem using u substitution. Start by choosing u as the inner function. In this case, 5x will be the inner function. And then find its derivative. So, u equal to 5x. When we derive, we will got du over dx equal to 5. Next, we need to change this function to become dx equal to du over 5 so that we can substitute it with dx in the next step. So now we can substitute u into the original problem. Therefore, it will become cos u times dx. Then replace the dx with the equation earlier, which is cos u dx is equal to du over 5. Simplify it using the integral properties, we will got 1 over 5 cos u du. Lastly, integrate the problem and don't forget to convert back to the original variable. So 1 over 5, the integration of cos u, we will got sin u plus c. Therefore, remember to convert back the u with 5x. We will got 1 over 5 sin 5x plus c. There we got it.